So I'm Gil Sylvia. I'm now semi-formally retired from Oregon State as director of the experiment station, but I'm still working on special projects. So it's an honor for me to be here today and to introduce our speaker, Steve Dundas. So Steve's an assistant professor in applied economics and the Coastal Oregon Marine Experiment Station. So he has a shared position. I'm going to come back to that here in a second. So just by background, he was hired here in 2015. He's an environmental natural resource economist with special focus on coastal and marine ecosystem services. So I don't think we've ever had a position like this at Oregon State, and it's pretty exciting, and we'll see here in a second why this position was created. So he has a BS in natural resource management from Delaware. He minored in resource economics, biology, and photography. And I'll come back to that here in a second as well. He got his MS at the University of Delaware in 2011 and his PhD at North Carolina State in 2015. Steve is a faculty member who hit the road running when he got hired here. A couple of awards he's already gotten. He was Distinguished New Professor of the Year in the College of Ag when he was in his first year of teaching. And he won the Outstanding Article Award in Marine Resource Economics in 2018. He's already serving on a number of statewide advisory boards. He serves on the Puget Sound Partnership, serves for Simmers on their science advisory group, and he serves on the advisory council for statewide planning of 18 beaches and dunes for LCDC. He has a ton of publications and grants. He's already averaging $1 million of grants per year, which for a new hire in social sciences is just amazing. So you got to keep that up. So there's the problem. He's setting an extraordinary standard for social scientists. And two other factoids about Steve. He worked as a photojournalist for an organization called Journal Publications and Inc. for 3 years. So he took that minor and put it to work in combination with science. And finally, and maybe the most important thing, Steve was one of 5 hires under the Marine Studies Initiative in 2015 by the Provost. This was a Provost special package called Hires for the Marine Studies Initiative. And the reason he's in both Coons and Applied Econ is both organizations asked for an ecosystem services economist. And so the deans in our college decided, well, let's join them together. And Steve's still trying to figure out who his bosses really are, right? Anyway, that's what happens with complex positions. But anyway, Steve, I'd like to introduce you. Thanks.
Well, thanks for the introduction, Gil. I guess it sounds like I have been busy since I've been to Oregon State. Today I'm going to be presenting some work with a PhD student who actually, I say PhD student, but he has his PhD now, and he's an assistant professor at Western Michigan. He finished in August. And he has moved on, but this was part of his dissertation work, and this is part of one of the grants that that Gil referenced that I started with from NOAA, looking at coastal natural infrastructure. So the idea was that that we know what protective services we would get from hardened infrastructure in terms of protection from flooding, but NOAA wanted to know a little bit about what we might get from natural infrastructure, the other ecosystem service benefits from, say, restoring a dune and beach ecosystem or wetlands rather than putting up a dike or putting up a seawall. So as part of that project, we wanted to see how the kind of gray or built infrastructure that had an interesting policy hook along the Oregon coast played into this kind of optimal management of the coastline. So what I'm going to present today is we're going to be looking at the decision-making process of landowners to decide whether to install coastal armoring or not to protect their private property from erosion, from flooding. With the trade-off being, because in Oregon, we have the beach bill, we have a permanent recreation easement that travels to wherever that vegetation line is. So the trade-offs to allowing people to protect their private property is that you lose some of that public space. So there's this inherent tension between the public good of beach access and homeowners' right to protect their assets. So we're looking at trying to understand that decision-making process, like what drives people to decide to armor. And you might think, well, of course, it's elevation, it's erosion, it's storm events, it's those kind of physical forcing factors. But we also decided to look at maybe it's maybe there's an additional dimension to this. Maybe there's a kind of social dimension where people are learning from their neighbors. Or if their neighbor decides to put up a structure like this, they become worried about deflected wave energy and spillover effects, that these spatial interactions between decision makers might be playing a larger part of the process than just the physical kind of forcing factors alone. So the motivation here is that nearly 40% of Americans live in coastal counties. Erosion causes lots of damage every year across the country. A recent paper in 2015 said, hey, we're going to lose about 9.3% of GDP by the end of the century if we don't adapt to sea level rise and erosion. So these anticipated adaptations are occurring already. These pictures kind of walk through different options around the country, but they also kind of walk through my history of studying this topic. I grew up not too far from here in New Jersey. New Jersey has a very built coastline, and they've already decided how they're going to adapt. They're spending lots and lots of money dredging sand from offshore and widening beaches and building up dunes. And I have a couple papers published on that topic of how that impacts decision-making in housing markets in New Jersey. I spent some time in North Carolina, and North Carolina, they're changing the rules as we speak. There's lots of kind of discussion about how they're going to adapt to climate change, but on the Outer Banks, they used to have they do a lot of this now on the Outer Banks. They're pumping tons of sand, but they used to say, you know what? As soon as your structure is undermined, like it falls in. It was retreat and defend. You can't really see here, but the amount of sand fences and dune grass plantings that these people in this row of housing out here is pretty phenomenal, because these houses have been condemned, they're going to fall in, and then they're trying to prevent them from being the next round. So there's certain areas of the Outer Banks where 6 or 7 rows of homes have fallen in over the last 20 years. We move to Oregon, we have a very different wave climate, a very different geology of the coastline. We have bluff-back beaches and dune-back beaches, and we have days where 25-foot waves and storm surges are not uncommon. I remember showing this picture to the Coombs Advisory Board, and I think it was Terry Thompson laughed. He's like, yeah, the first winter storm would just wipe out that entire island. And he's probably right. The wave climate there is much less volatile and less big. So beach nourishment for the time being is their strategy for kind of adapting to sea level rise. It's becoming a regional issue out here. There's been lots of headlines about California facing these trade-offs of do they save the public beach, or do they allow these bluffside homeowners to try to save their properties. There's been some research and anecdotal evidence that beachfront properties are starting to lose value, that the boom of coastal real estate is coming to an end because these coastal threats are starting to become more apparent. And then we have this one particular house in Oregon that was the reason that I got interested in this issue, and at least drew me to this idea in Oregon. And this, if you're not familiar, this is the house in Rockaway Beach that is at the center of kind of a riprap battle. So in the state of Oregon, we have Goal 18, which is a state planning goal that regulates coastal use of beaches and dunes. And what it also does is it delineates, it also includes a prohibition on armoring or installing hardened structures. But to avoid the takings under the U.S. Constitution, the Fifth Amendment, when they put the law in place in 1977, they allowed any property that was developed to retain the right to armor, which has created an interesting policy dynamic current day. So this particular house, and this quote is what kind of was the genesis of this idea, like how can we model this behavior, and how do we know it's not just big waves and erosion that are driving this decision. Maybe people are, that the spatial patterns of how these decisions are made might be affected by people interacting in different ways. This particular neighbor said, don't let them do this, because if you let them do this, then I'm going to have to do it next year. So okay, maybe there's some interactions, spatial interactions that we should explore. So our research questions are what factors impact a homeowner's or landowner's decision to install shoreline armoring? And I will say, if you have any questions, just please raise your hand or interrupt at any point. You don't have to save them for the end. Is it solely the risk characteristics of land, or are there neighboring effects that might be helping drive this decision? And then we do find that the effect of these spatial spillovers is quite important in driving the probability of observing and armoring decision in any given time period. So given that we've kind of identified evidence of these kind of information spillovers, how is that going to matter in how this private adaptation to sea level rise and increasing erosion might spread over time and space in the future? And so we use parameters from our estimated econometric model to kind of simulate into the future and try different policy scenarios. We add sea level rise projections to it. We add different changes of current Goal 18 policy to it and see how that might change the total counts and the spatial distribution of where armoring might occur on the coastline. So key results, just a preview, is that these spatial spillovers are highly influential determinants of a particular landowner deciding to choose to armor. We take our model without spatial spillovers and run a simulation out for 40 years, and then we take the model with the spillover effects. We see a substantial increase of about 65%, indicating, that spatial spillovers are a critical component of how these decisions are made. Using that spatial spillover model as our baseline, worst case scenario sea level projections, as you would expect, do increase the amount of armoring. Another key takeaway here is that policy matters. If we removed our current Goal 18 policy and allowed anyone to armor, we'd see another 70% increase over the next 40 years, which would be, I think, up to, you'd see 40% of the coastline of Tillamook and Lincoln County armor in the next 40 years. So in one respect, current Goal 18 policy is preserving some public good aspect of the beaches, but it also signals that there's going to be conflict as private homeowners start to experience adverse effects from increased erosion. Okay, so that's the 30,000 foot view. So we'll start kind of walking through some of the details. So we have the beach fill, we have this permanent recreation easement, and after that came the estate planning goals. I love this quote. Tom McCall, the curb sagebrush subdivisions, coastal condominium, and the ravenous rampages of suburbia gave us our estate planning goals. And we have the first 15 were passed in 1975. The ones that govern coastal resources, 16 through 19, were passed in 1976. So as I mentioned earlier, Goal 18 was one of those coastal land use goals. And the idea here is it's trying to protect Oregon's beaches and dunes in the spirit of the beach bill, reduce risk to infrastructure from coastal hazards, and prohibit people from doing things in the coastal environment like dune grading or constructing hardened structures that aren't consistent with kind of the land use planning goal. But again, to avoid the takings clause in the Constitution, anyone who had developed property on the oceanfront prior to January 1st, 1977 retained the right to install armoring at a future date if their parcel became vulnerable to erosion. So again, it's this fundamental trade-off between a landowner's property right to install a protective structure and kind of this idea of public access. I mean, this was a day in Nesquin maybe 2 years ago when I took this picture, and it was low tide. And if you've been in Nesquin, at some points where the armoring structures are, you can't get by at high tide. So there's this kind of fundamental trade-off between losing 30 feet of beach that is granted as public access under the beach bill versus allowing private property owners to fix that shoreline in place, to deflect the wave action, to stop the erosion and the land loss on their property. So map of the coast, the red dots indicate where there are these shoreline protective structures, these armoring. As you can see, there's a pretty high concentration in the northern 3 counties. As you'll see, there's a pretty data-intensive process that went into our model. And we needed to limit the geographic scope, so we focused on where 90% of the armoring had occurred, which was Lincoln and Tillamook counties. So to give you an idea, there's about I think this is wrong, I think there's about 9,500 coastal parcels in Oregon. DLCD, who keeps the records of eligibility, says they're about split. About 4,500 were developed prior to 1977, retain this right, this eligibility to install armoring. Another half are not eligible. And then we have 2,800 of those eligible parcels in Tillamook and Lincoln County. And as of 2015, when we started the study, the data that we're using, about 1,200 of those parcels were armored and 1,600 1,600 were unarmored. So that means there was 1,600 parcels that retained the right to install these structures at some point in the future if their property became at risk.
So that's actual property, not the owner, so it's grandfathered into the property.
Yes. Yeah. We could probably spend the rest of the time debating whether that was a correct interpretation of the planning goal or not, but yes, the right has stayed with the parcel. So to give you an idea of the data that we need to try to pull off this model. So we're trying to estimate a kind of a discrete choice model from a landowner's perspective. Did they, in a given time period, did they armor or did they not? And what are the things that influence that decision? So we put together a pretty, most of this project was putting this data set together. We from USGS surveys and other sources, we found short-term and long-term erosion rates at a scale that could be attributed to a parcel. We used at least 6 different LiDAR images from 6 different years to approximate the structure footprint and measure how first the setback distance, so basically the structure to the vegetation line, which gives us a kind of a measure of risk, how close that vegetation line is to the undermining structure, how far the house is from the mean high water line. We also have data from a vendor and from the counties that give us information about the individual parcels, the real market value, the characteristics, acreage, excuse me. And so we can use those NGIS tools to kind of measure and calculate a number of relevant risk factors or amenity factors that might go into this decision process. From Oregon State Parks, we also have a database of where these structures are when they were installed through their permitting database. So we know when homes decided to do this and when these structures, and we have maps of when these structures appeared. So in this particular case, these red lines indicate where there's currently installed riprap structures, and you can see just in this case that there's some spatial variability. And what that then builds for us is this kind of way to capture the interactions between neighbors. So we have this spatial variability. So it says, you know, this person's decision to armor, who's next to this person that already has armored, yes, it might be influenced by erosion, elevation, other things, but it also might be significantly influenced by the fact that their direct neighbor has already made that decision. Yes?
Do you look at if those houses are permanent residents or they're owned by people that are renting those houses out?
It's a great question. I just recently purchased a data set that is hopefully going to help us try to uncover that information to see if we can tease out if that is part of the decision process as well. Intuitively, I would say that if I own it and I live there, I'm going to put off riprap. I'm going to want to install riprap because I want to protect my property, but I may do it maybe sooner than if I was renting it out, because as soon as I put up that structure, it might limit access, it might disrupt the aesthetics of the property. So there could be different kind of influences that we could tease out by those groups, but currently we don't have that. We don't observe that, but we're trying. So it's a great question. So to give you an idea of what the historical patterns have been, so this is the count of armoring that have occurred along the Oregon coast from 1967, which when it was kind of unregulated. Regulation started here, and what's been going on since then. Anybody want to take a guess what the 2 spikes were? El Niños. So key thing that we have to control for is, yes, if we observe armoring occurring in 1984 and 1999, El Nino is occurring. So we include effects for like high storm seasons. And we also include them in our simulations. We kind of throw that kind of effect that we measure from that storm season at the model every 15 to 17 years.
See, for those El Nino years, was there a component of emergency approvals for permits that wouldn't otherwise have been permitted during those storm years? You know?
My understanding is that a lot of what was done in those years was on an emergency basis, but the homeowners then had to go through the actual process and obtain a non-emergency or a permit post-emergency. Right? It's there's no one really around that has been able to speak about the 84. My discussions with state parks on kind of the one in the late 90s, I don't get the sense that there was a lot of exceptions made for parcels that did not have eligibility. That, say, the big example there was like Nesquilin and Rockaway Beach, like big stretches of armoring went in on those coasts at that time. And as far as I can tell from all the records, they went in on eligible parcels. So this landowner decision problem, this is a discrete choice problem. It's do we install or do we not? And so we have the data that we use. I don't think I put it up here. It's 1995 to 2015, or 1990 to 2015. So we have 25 years of data, 25 periods where we either observe this decision to armor or not. Because we're trying to go after these spatial interactions, we run into what economists term as identification concerns. Are we going to be able to identify the effects of these spatial interactions appropriately, given some kind of complexities of how people might interact? And I'll talk about these now. So Mansky in 1993 brought up these ideas that it's not straightforward to kind of estimate a model where you're trying to estimate the effect of peers on one another, like the peer effect. First problem he noted is the reflection problem. Which peer is influencing who? Like if you observe simultaneous decisions of people choosing to armor, is it parcel A or parcel B that influence the other one? So how can you determine the direction of correlation or causality because of the simultaneous? So that's problem number one. Problem two is what's called a correlated effects problem. Peers tend to act alike due to being alike. So you have to be able to understand how the peers interact in some way. We're going to achieve that by kind of putting a spatial network together where we are imposing some structure on that behavior, and then we test our assumptions about how those peers might be interacting. We also have what are called endogenous effects, that individuals might make decisions that vary in a way with the peer group decisions. So that's also captured by how we structure the adjacency and the interactions between the peer groups. And there's also contextual effects, so saying that someone else's characteristics. So if I look down the beach and I see my neighbor 3 doors down, their beach is eroding rapidly, is the erosion on their parcel influencing my decision? So there's like many layers of how this spatial interaction could occur that we have to try to control for to give a credible estimate of how we're potentially estimating the power or the influence of these spatial effects on the decision-making process. So now we have 3 slides of math. I'm going to try to go through these quickly. So we specify a land value function. So we're saying that every parcel has a value and that there are things that influence that value. And they're only going to choose to armor when the expected value of their parcel in an unarmored state becomes lower than their expected value in an armored state. So basically what this is saying is that the parcel's value is dependent on X, which are the observable characteristics of the parcel. It's the things that we observe. Capital S is the number of direct neighbors that might have armored. Now we call that a spillover effect. And we're calling little s, which is people in your neighborhood armoring, having a peer effect or an information effect. So we think we can clearly identify the peer effect. The spillover effect of the direct neighbor, we can't tease out whether it's a learning effect, whether it is a true peer effect, or it's related to a spatial externality, where if I armor and my neighbor doesn't have armoring, the wave action on a day like today would come in, deflect the waves away from the parcel that's armored, and accelerate erosion on my property. So it could be this thought that, hey, my neighbor has armored, I'm now more at risk, I should armor too. Or it could be something as simple as, hey, I think I need this too. Which contractor did you use? Oh, okay, cool, he's available now, I'm going to do this. So it could be some kind of learning effect from being a direct neighbor. We don't observe anything to tease that out, so we just kind of call it the spillover effect of the neighbor. Cap A is our adjacency matrix, which kind of establishes that peer relationship for little s. Our delta is a wave year fixed effect, so we're trying to control for all things that might happen to parcels in a given wave year. So typically in economics, you see fixed effects at the year level to control for macroeconomic trends. everything that happened in 1999 happened to everybody. We don't observe everything, but we can kind of control for that kind of macro effect. Here we do a wave year. We say from April to March, which captures all the wave action on the Oregon coast. It's common to all properties on the Oregon coast. That captures those risk factors that we don't observe. We estimate a Probit model, which is a kind of a way to estimate a discrete choice model. We start running into our identification issues. So we have repeat observations. So we have a panel of data. We observe each parcel over time. In an ideal world, we would put in another fixed effect that said at the parcel level. So we would control for anything unobservable at a parcel level that might contaminate our results. However, that would soak up our ability to identify anything that's time invariant. So like long-term erosion rates would get soaked up into that fixed effect. And we actually care. We want to know how long-term erosion rates are affecting the property. So in terms of identifying these effects well, we can't rely on our traditional strategies of just using these kind of fixed effects. So what we do is we adopt what's called this Munlock device, or correlated random effects. So what we do is we assume a form for the unobservable time invariant component of the error term. That is the time average of the time invariant characteristics that we do observe. And the theory and the model show that it essentially performs the same role as a fixed effect, but still allows us to estimate impacts of time invariant components in the model. So what it does is it means we have to estimate more parameters, but it gives us a better set of assumptions to base our model on. When we get down to the other issues I mentioned on identification, group definition, simultaneity, and contextual effects. So we are imposing a structure on how these, a minimal structure on how these neighbors might interact, just by defining kind of an adjacency barrier that we can test. We try to overcome the simultaneity problem by lagging the decision so that capital S and the lowercase s are if our neighbors armored in the previous period. That kind of fits the decision of armoring well because there's a permitting process, there's an installation process. If I observe my neighbor choosing to armor in October, chances of a simultaneous decision on my part is fairly low. I may watch and observe what happens, and then in that next period, that installation in the previous period is going to affect my decision. We also test out that assumption, but a common way to overcome the reflection problem is to just lag the variables of interest. Okay, so the models take a long time to run, but well, actually the models don't, but the simulations that are coming up do. Our empirical results. So the model of this kind of 25 years of observed behavior of these landowners. All the things that you think intuitively would matter. Higher erosion rates increase the probability of armoring. If they're farther from the shoreline, then they decrease the likelihood of armoring. Economic factors, higher value properties tend to armor more frequently. Because we don't directly observe the costs of installing these armoring structures, we have estimates, but we don't observe parcel level cost. Our best guess for how that's manifesting in our model is through parcel size, and showing that the larger the parcel, the bigger the frontage, means the more expensive the structure that I have to install, and that's actually decreasing the likelihood of armoring. Yeah.
Would it potentially be the reverse, that larger, more costly would be associated with someone with much higher income and more disposable to?
Could be, yeah. I mean, that is the result, and that's kind of our current interpretation, but only because the reviewer came at us like, where's costs?
I've dealt with this stuff for over 15 years, and I can guarantee you that's exactly what most of the time it is. These bigger houses often tend to be secondary houses and whatnot, and they're just protecting their investment.
Right, and so I would argue that we're picking that up through the kind of real market value of the house, and then separately identifying this kind of, it's not saying that if I have a large parcel that I'm less likely to armor. It's saying that the fact that it's large, the cost might be a slight deterrent on the probability, but they're still going to do it if there's risk and it's a valuable piece of real estate. So I would say that most of what came out of our model is quite intuitive, and which is good. If you're trying to build the model behavior where you think you know what is driving these decisions, it's good that the model will kind of bear that out. So then we move to, so we did a model with just risk factors, just direct neighbors, and then direct neighbors, and this peer effect. And the numbers, the magnitudes are difficult to interpret with this type of modeling estimation, but the key thing to notice here is that the sign, the magnitude, the significance are consistent across models. And then when we get to the peer model, we can see that, hey, there's a big effect from an El Nino storm event, a big effect from having my neighbor decide to arbor, and a significant effect when the number of parcels that are armored in my neighborhood increases. So these peer effects and these spillover effects also seem to be significant drivers of that decision-making process for landowners. Okay, so that's our empirical model. So I kind of built you up with all the assumptions and the things that we were trying to do. Well, in our field, that's great. You build your model, but then you have to try to break it to prove that these decisions that you made and the assumptions that you made aren't driving your results. So we tried different specifications of how we specified the decision problem. We tried different, we stuck with the correlated random effects model, but we tried using time trends, different fixed effects. We tried lagging or not, trying to overcome the reflection problem. That adjacency matrix, we tried 15 different specifications on how big or small that the peers could have influence on one another. And one thing that is important that we tried, but is that working with some coastal geomorphologists who had some data for about 20% of the parcels in our sample, which was how many days water levels exceeded a certain threshold, which gives us another really fine-scale dimension of risk, of things that might drive. And we added that to the model. Obviously, we had to reduce the number of parcels involved because we didn't have the information for all of them. And everything was still consistently signed in magnitude. And currently working to develop that total water level measure for the entire Tillamook and Lincoln County, and actually the entire Oregon coast. And we're working to try to integrate these models in a better fashion, and I'll talk a little bit about that later. So our empirical results don't really tell us anything we didn't already know, right? They did tell us that these spatial interactions matter, but they also confirmed our hypotheses about what physical risk factors might be driving these decisions. So we can take our model parameters and start running through kind of Monte Carlo simulations to understand what the future might look like. So we've used 25 years of data to estimate a model. We still have 1,600 parcels that have this right. How are they going to behave given the landscape in 2015 simulated out over the next 40 years? So we have, in the simulations, we have information about all the parcels that are ineligible and that also haven't armored yet. We control for changes in erosion rates and shoreline, so we have we step forward some time varying risk factors that we step forward at different times in the simulation. So basically our general process for simulating these future coastlines is that the model will go in, pick a parcel, it'll calculate the predicted probability of armoring from our model, it'll take a random draw from a uniform distribution, compare those two probabilities. If the predicted exceeds that random draw, then we consider that parcel to have armored in that period. And then we loop through every parcel on the Tillamook and Lincoln County coastline. And so that would be 2016. 2017, we would then update some of our time-varying risk factors. We would update capital S and little s with the armoring that occurred in the previous period. And then we'd run through again, start drawing the parcels that have not armored and seeing how that goes. And we keep looping through, and we go 30, I think 40 years out into the future. So here's kind of the one graph that summarizes all of that. So that lower line here, this dotted line, So we did 200 simulations of each of these. So that lower line is that baseline model. That's the model that has real market value, it has parcel size, it has erosion rates, it has elevation, has all the risk characteristics associated with the land, the parcel itself, and the model. The dotted line is the counts over time when we include the effect of the direct neighbor. And then the solid line is when we include the interactions or learning effect from peers in their neighborhood. The simulation, as you can see, El Nino events occur about every 17 years. We turned on the effects that we found for the El Nino, for the storm event, at period 17, which is why you see every model kind of climbing upwards after that. And then at year 34, we threw another event in there. So what this is telling us is that without the human component, the behavioral component, how these landowners might be interacting, we run the risk of not being able to see the true amount or predict the true amount of how this coastal armory decision would proceed over time. So the difference here is the 66% increase going from our baseline model to our peer model after 40 years. So our takeaway message there is that these are just simulation exercises. You know, we say 230 and 381. Those numbers are slightly meaningless. Those are the averages, total counts over these 200 simulation runs. Just the magnitude of the difference gives us pause and say, hey, maybe we models that aren't taking into account that people interact with each other and that might influence those decisions might be an important factor to consider if we think about how these decisions might be made going forward. So that was the first simulation, just to test the magnitude of the effect of those peer effects across a simulated landscape. Given that we now have a nice simulation built, we said, okay, well, let's play with the policy scenarios and sea level rise a little bit. So my understanding from the state of Oregon is they have no interest in making it more restrictive. So any scenario where we said, okay, we're gonna cut off armoring for X number of parcels isn't in the cards. There was a focus group from June through August that we met for 3 hours every month. This year, there's a final report available online if anyone wants to see the results of that focus group, but it was sitting in a room trying to figure out how to proceed given coastal threats, sea level rise, private property concerns, and the beach bill. This is an issue that's going to come to a head, probably in court, but the idea was that let's figure out how to take Goal 18 forward. Results from that said there's no clear, credible counterfactual we could do other than just showing the power of the current law. So we just decided to stick with one instead of trying to make those decisions about, well, which parcels are going to now be eligible and which are not. So the counterfactual that we looked at was just eliminating the prohibition on armoring altogether. Sea level rise, we took worst case levels of sea level rise from NOAA along the Tillamook and Lincoln counties and kind of crudely incorporated them into our model. So this is future work. We're trying to do this better. But if we said sea level rise is going to go up 2 inches, then we reduced parcel elevation by 2 inches relative to sea level rise. So we updated elevation based on change in sea level rise. We were also fortunate to find data on shore face slope. So you have the slope of the offshore is going to translate how much a sea level rise will bring the water forward on the beach through a simple rule called the Bruin rule. So we had estimates of sea level rise, we had measurements at the partial scale for shore face slope. So we were able to kind of advance or move back the distance to water measure to kind of reflect sea level rise within the simulations. So another picture. So this is using our peer model as the baseline. So that's this bottom line was the top line on the previous graph. The big jump is if we remove Goal 18 completely. And what that says is about 70% more parcels will decide to armor. So there's a lot of pent-up demand for coastal armoring. There's a lot of parcels that just simply can't do it now by the state law that would do so over the next 40 years, given the opportunity. The black line on top of that is when we added in the worst case sea level rise scenario. So it's not a direct interpretation, but gives you a sense of the magnitude of the variability of how this might proceed if with climate change and with policy. Policy is the one that matters here. Yes, we're going to see changes with sea level rise, but policy is what matters to driving how our coastlines will look in the future. So our takeaway messages are that spillover effects, interactions between neighbors are important. It appears that goal 18 has been pretty good at limiting shoreline armoring, and our simulation suggests that it's preventing 300 to 400 parcels from doing so over the next 40 years. However, that means 300 to 400 parcels are going to be at imminent risk of structural collapse at some point in the near future. So we have a problem on our hands, and the current legislation, current planning goals has a plan to do it, and people are starting to get worried about how the planning goal and the coastline in general might proceed given sea level rise. With projections of sea level rise, we do predict an increase, although the magnitude is not that high relative to the other differences that we've been finding, and just shows that the elimination of goal 18 could produce a lot more armoring on the coastline in the near future. So policy matters. I wanted to leave 15 minutes for questions. Looks like I have 2 minutes left, so I'm going to just kind of point to where this research is going. So this is a paper that's going to be under review momentarily, hopefully. My student will be putting it under review. So where we're going now is we're working with coastal geomorphologist at OSU, Peter Ruggiero, and one of his grad students who's working on a Tesla model. I can never remember what that stands for. Someone in this room might. It's a time-varying something, shoreline something something. It's a model that takes in wave climate and a lot of other things and can predict total water levels at a fine scale along the Oregon coast, both observed and projected. So that's where we got the information, a test run of that model for a few parcels. That was one of the robustness checks we threw in there. They're about to finish a model that will give us that for the entire coastline. So that's the next update is more information about risk. Now, my colleague Peter doesn't know this yet, but I'm really going to push him to see if we can couple these models. But if Tesla can handle hardened structures and how that might influence total water levels. So in my ideal scenario, we have our model running over a year. We give a new position of armoring. It goes back to Tesla. Tesla can handle that armoring and give us total water level projections that may be altered by that armoring, and we can iterate back and forth to get a better predictor of how the decision-making process might be going. We're also trying to actually simplify this model to kind of some simple decision rules to get it into an agent-based model. This is an Oregon Sea Grant funded project called Envisioning Oregon's Coastal Futures. So previous iterations of this model, there was a project in Tillamook and Grace Harbor, and they were using simple kind of decision rules. Hey, if the water gets this high, we armor. And what we're saying is, hey, there's more factors that play into that decision. That's a crude rule might be good for kind of a big picture scenario, but we can do better. And we're trying to figure out how to take what we've learned from this model and kind of simplify it into that integrated model to make that decision process a little bit more realistic. With that, I will thank you and take any questions that you have. Yeah.
So we deal with this a lot on the coast, obviously, and for a lot of the resource agencies, we look at it from a natural resource protection standpoint. So with this, it seems like if you can add in, this is awesome, we use it as a source now for a lot of things. But if you use your ecosystem services and put an economic value on that to show that if 70% more gets increased because of this, of what's going to be lost from that point of view, that helps give a lot more information to decision makers whether or not something gets changed.
So I have funding to do that.
Yeah,
And I'm working on that component of what's the So this is modeling the landowners' value and decisions.
Right.
How do their decisions impact the public value for these beaches? That's my next question, and I can probably answer that in a couple of years.
Yeah, and then are you providing this information, I assume obviously to like state parks, but then the Army Corps of Engineers, the Department of State Lands, since they're the ones who do a lot of these permitting things, and then so that they can utilize this information? Because a lot of what you said is well known, but now we have some data to show them and to show landowners.
So I presented this, and I've also done a study with another co-author at OSU where we looked at the option value, how housing markets were influenced, because there are have and have-nots. They're eligible and not.
Yeah.
So I presented on that and this to DLCD in May at the focus group, with members of state parks being there. We have someone from the Port Office of Army Corps of Engineers on our advisory board for this grant.
Yeah.
So I'm trying to get it in the hands of people that are making these
And then
decisions.
have you guys looked at the soft armoring techniques, not just riprap? Some places they only use riprap, but there's a lot of opportunity to use less invasive methods for armoring.
Absolutely. So I've done work on that with nourishment and dune building on the East Coast. Part of this project, one of the co-PIs, Peter Ruggiero, is working with, there's a homeowners association in Pacific City that's trying out different, they've been trying for years to establish grasses to stabilize the sands, and they're trying to take, from another part of this project, trying to take findings from the ecologists about how to do it, when to do it, what types to do. So there are efforts ongoing. I've seen a few permit applications recently where they put the riprap and then they
Make them do,
they say they're going to put sand and plant grass on top, but that doesn't last very long. So yeah, and then there is ongoing work to try to figure out, hey, what's the, for a wider stretch, including not private property houses, what's the optimal way to think about managing coastal dunes and beaches in Oregon? Because we have invasive beach grasses, there's endangered species, there's protection from flooding, there's a whole bunch of trade-offs involved with that decision process. So
I did bring it up because on inland, where you have more leeway to use more soft armoring versus right out on the headland. So we push that more often, but obviously the beach is a much different dynamic.
yeah, I can't imagine a scenario where beach nourishment would be economical or effective with this wave climate.
I do have a question. It's probably a little outside of what you're talking about, but so we were just talking economics. But is there any? So if I have had property and I armor it, and my neighbors don't, so it's going to change the dynamics of the waves of either side of me or whatever. I mean, why would they not allow someone to armor?
That's a great question, and I think we spent a lot of time at the DLCD focus group talking about just that. If you talk to the people that study coastal geomorphology, I think that there's not a single paper that they can point to that says there's direct evidence of scouring or these deflected wave energy, but it is something they think is happening. And you just run afoul of the current land use planning goals. If you have a situation where you have a house that was built in 1975 and the neighbor was built in 1979, just the way that the current the kind of, they call it the sawtooth pattern of how this eligibility works was actually the subject of the meeting that I presented in, and a topic of discussion, like how there's got to be a way that we can better handle, and that was one of the simulations I proposed. But then deciding who, then you're kind of playing with policy in a way that affects people directly. You're making choices of which parcels that are neighbors of people that have the right to armor do you include and which do you not. And DLCD wasn't ready to do that just yet.
So who owns the riprap? It's on public property. Can you walk on the riprap?
So that's another thorny question. So technically, in Oregon, the private property goes to a statutory vegetation line that was decided a couple decades ago. Beach Bill says there's a permanent easement, public can access to the actual vegetation line. So in a lot of places, there's an easement to access the beach, but it technically is still private property. So the people who are building these structures and have the are eligible to do so have a right to put it on the beach, because technically they still, because of erosion, the statutory vegetation line and the actual vegetation line don't match up, and the way the property right laws are written, they can install the armory on the beach.
If you're walking the beach, can you walk on that armory, or are you typically on their property at that point?
I don't know.
You can't infer from the presence of the armor whether or not you're above or below the statutory vegetation line.
Yeah.
You can go to the map and find out whether the actual vegetation line or the statutory line is seaward of which of the other. And the park's jurisdiction runs to the landward of the two, whichever is further landward. So it's complicated.
Yeah.
Just do it.
I know it's hard to estimate how long a structure like that is going to last,
Mm-hmm.
but it seems to me with the accelerating rates of sea level rise, everything you're talking about is probably about a 30 or 40 year horizon, at which point the property behind it is going to be inundated so often that unless you start building your structures higher than that property,
Mm-hmm.
this is just extending the inevitable, right, for
Right.
a couple decades.
Yeah, that's a good point. So to give you a sense of what I've determined, that from just anecdotal conversations, is that the approximate cost of one of these is about $30,000 to $50,000, which, if you look at the average property value, is about 5 to 7%. So I look at that and say that's relatively inexpensive relative to the value of the asset that it's protecting. I do think maintenance costs are increasing rapidly. Like storm events like today could knock out big rocks, and they have to pay someone to come fix it to maintain the efficacy of the structure. I do know that the one place on the coast that has actually had conversations like you're mentioning is Mesquite. Mesquite has kind of came together as a community and has kind of thought through this process, is that, hey, we need to make these structures tall, make them big, and allow them here, because there are 10 rows of houses behind where this is protecting everybody, not just the people up front. I do think that the issues that you point to are going to require kind of local conversations about the direction given future risks. I mean, those type of conversations need to start happening. They are in a few places. Like I know Del Mar, California has basically said, we're not going anywhere. And so they're going to just start building these large seawalls to keep it out, because they don't want to lose tax base. People want to live there. So they've said, they've applied to the California Coast Commission and said, nope, we're doing this. We're not retreating. Places like New Jersey have decided, we're going to just keep relying on the federal government to keep pumping sand out there. And they've instituted what they call a Blue Acres program, where they're trying to buy out vulnerable properties to create more of a buffer. There's some social environmental justice issues there. They're protecting beachfront homes that are owned by wealthy people, and they're buying out poor communities. So there's some issues of how that's being implemented. But those conversations need to start happening, I think. Go.
Yeah, so the role of insurance companies in all of this, have they changed fundamentally the way they do insurance, or would we expect to see changes in insurance policies indirectly affect home prices, for example?
Great question. In Oregon, I'm not exactly sure how erosion and protection from riprap is going to play into homeowners insurance, because it's not right now, as of right now, it's not a flooding issue. So it doesn't, if you look at the damages from coastal flooding in Oregon over the last 20 years, 99.7% of them are estuary flooding. Like flooding damages on the coast, it's more of this kind of, I'm losing property and I'm undermining the land where my house sits. So it's more of an erosion protection, and I should look into this. I need to know how erosion protection might play into, say, homeowner premiums. But are you trying to direct me to give my opinions on the National Flood Insurance Program. I'm going to.
Well, I can imagine what your opinions are on the National Flood Insurance Program.
But so, for example,
Perverse incentives.
yes, there's. I just heard on NPR. There's a Washington Post journalist that I forget the name of the book, but he just put it out yesterday. It's intriguing me. It's basically laying out the ridiculous incentives and the ridiculous policies for coastal development that we have, and how we're headed down a really dark path if we keep doing what we're doing and rebuilding after every storm and incentivizing people to invest in infrastructure and assets in places that are doomed to fail.
So what's your interpretation of what a peer effect is? Is it just a behavioral interaction between homeowners, or does it include things like, if I live on this property and I see that the creek mouth that's 3 properties down is migrating south, and it takes up, the property 2 doors down, and then my neighbor armors, and I can see that coming. Is the geological proximity also a peer effect? My peer has an impact, and that causes me to do something, or is it just the decision-making process?
It's a great question. So the little s, that what we were calling the peer effect, is trying to capture, hey, I witnessed someone in my neighborhood, in my area, might not have been my direct neighbor, but someone 5-6 houses down armoring. And I'm learning from that. Either we can't identify how that learning is occurring, but then we also control for the factors that exist on those other parcels that may also influence our decision. So that was an additional component. That was the contextual effect. That if we didn't control for that, then we might either overestimate or underestimate the effect of the peer effect. So we try to control for the fact that, hey, I'm witnessing erosion going on 3 parcels down. So we kind of threw that into the model as well, saying, hey, I'm cognizant that I might be learning from kind of these exogenous factors, but I might also be learning from the decisions of my neighbors. So we try to separate them. Whether we did that well enough is up for the reviewers to decide. But
in your scenario, then, when you're talking about under a goalie removal scenario, which I agree isn't a likely one, but
right.
Shows the importance of the goal. Do you assume the behavior is the same in the sense that the prior landowners who had properties that were allowed to riprap under the idea is that everyone would behave in the same way, even though they might have been a recent acquisition. They might have recently acquired property knowing that it's not eligible, so they might not be subject to the same set of expectations about their ability to riprap or not.
Yeah, so that is a limitation. So we are assuming that the people that own ineligible property, if given the right, would behave in the same manner as the modeled behavior of the people that were eligible. Yeah, that's a good point. But yeah, that is a limitation because we don't have any data to build an empirical model of how they might behave. So we assume that they would behave in a similar fashion to the people that have the eligibility.
You may have spoken to this, but is there any knowledge about the relative risk of eligible and ineligible properties? As in, low-lying ones might have been the first to be acquired and were more likely to be grandfathered in, or anything like that?
So we deal with that a lot in the other paper I mentioned, where we try to look at the value that home buyers and sellers have placed on eligibility. So the idea is that the parcels that were eligible, that were built first, probably were built there for a reason. That maybe they had better amenities, they had better views. So that was a big part of our model there, was trying to control for the fact that the 2 groups were probably significantly different on observable characteristics. So yeah, we were just modeling eligible parcels. So we didn't, and we made that leap for that policy scenario just to say, okay, well, we think the ineligible people would behave in the same manner. Yeah.
When the homeowners apply for a permit, is there a public comment period, or?
Yes.
Yes.
Okay, so what I'm worried about is a community effect. So if there's strong community in the places where they're applying for a permit, are you picking that up in the model, or is that something that you looked at or thought about?
In an ideal world, we could claim that would be kind of picked up in those measures of the spillover effect. We're trying to capture, that would be a mechanism for people to learn about armoring and the risks and what's going on in their neighborhood. Right now we can We can posit different reasons why that might be occurring, and that could very well be a strong one, but our model doesn't have an ability to say this channel is why this peer effect is happening. It's just saying that, hey, we do think there's some learning going on. We can hypothesize about why, but we don't really have enough information, observable information about all of these decisions to kind of decide what mechanism is driving it.
Yeah, one of my thoughts is if you are in a community with a lot of permanent residents, that there might be more community effect versus if you're in a community like I live in Yachts, and I'm pretty sure most of the coastline is just rental houses.
Mm-hmm.
So might be less of a community effect there.
Yeah, that's a great point, and I think it ties to your question earlier. So I will say that that's definitely something that we're going to try to figure out, but we don't have a good handle on it yet. Is there a hand over here before?
Yeah, a couple quick questions for the online group. The first one is, someone just wanted to confirm that the state has to approve you to armor or not.
Yes, so I kind of glazed over that. So you have to apply. You have to be eligible, and then you have to apply to state parks. And with that application, you need a geologist to lay out what the risks are. Are you at imminent risk of some significant damage to your property? And they recommend the type of structure and placement. So part of your application to state parks is this kind of geologic assessment of the risk. And you have to meet some threshold in order to get that approval. So there is, you can't just, even if you're eligible, you can't just throw rocks out on the beach. You need to prove that you have a significant risk to your property.
And then secondly, would the foundation firming used on the new MSI building help a rich oceanfront property owner?
Say that again?
So the foundation firming method that was used on the new MSI building,
Okay.
would that be useful to a rich oceanfront?
That is an engineering question that I have no idea, but but I will give an anecdote. So I grew up in New Jersey, right where Superstorm Sandy hit. There was a picture in the New York Times of an old inlet that ripped back open. 15 huge mansions were destroyed, and there was one house sitting in the middle of that old inlet that ripped open. And I actually got to talk to the guy who owned it. He bought the property in 1981. He did his due diligence and said, wow, I just bought a property that used to be an inlet. I'm going to drill pylons to the depths that no one else is going to. I'm going to stick my house up higher than everybody else. And people gave him crap for it, but for 30 years, he was that odd house that was just taller and that he spent way too much money on, but it was completely fine.
So that has an island?
No, because the Army Corps of Engineers showed up and shut the inlet back up, and people have rebuilt all those houses already. So, but yes, you can. And that points to the significant problem in this country is that there's no incentive. The risk that you take when you buy property, you don't internalize it because there are subsidized insurance programs, there are disaster aid, there are things that make you not have to internalize the risk and take the appropriate actions to protect yourself. There's a few indications where people have done that with Katrina, with Sandy, with these other storms. I think Matthew that hit Florida pretty hard? I don't know, there was two houses that were fine when the entire town was destroyed. And again, those people knew the risks and they internalized it and they built appropriately. So there definitely are engineering ways to do this. However, our current policy and incentive structure is just not geared for people to actualize the risk themselves.
Why don't we wrap it up? So, and did you notice there wasn't one question you guys asked that wasn't excellent? That's excellent question. That's a great teaching method, by the way. Anyway, let's thank Steve for a great talk.
Thank you.
Like,